Yeah. Tejama, Shravanti is in the class, right?
Yes, sir. Yeah.
Ah, okay. So we'll start at 3:35.
Sure, sir.
Aditya, maybe you can share the screen and check everything is okay.
Sure. Is my PowerPoint visible?
Yeah. Is it visible to the class? Somebody, Tejama,
Yes, sir. Yeah, yes, sir.
and is his voice audible through the class?
Yes, sir.
Yeah. Okay.
Audible, right?
Yes, check, check.
Yes, Aditya, sir. It's audible.
Yeah,
Thank you.
okay. Fine. Aditya, will your video be on when you are speaking?
Yeah, yeah, I'll turn it on.
Yeah.
I'll turn it on. Yeah.
We are recording your talk. I
Sure.
hope it is there.
Yes, no problem.
Also, we'll need your slides later.
Sir, shall we start?
Yes, please do, please.
Yes. Hello, everyone. Today we have a guest lecture. So today's guest lecture is by Professor Aditya Joshi. He's a senior lecturer in the School of Computer Science and Engineering in UNSW, Sydney. He finished his master's and PhD from IIT Bombay with Pushpuk sir. So in the topic of computational sarcasm, which is a very important topic in NLP. So he also got Best Thesis Award from IITB Monash Research Academy. He has publications in all top tier NLP conferences like ACL, MNLP, like all Star CL, Polling and CoNL. So he also co-authored a book with Pushpak sir in NLP in 2023. And also from my seniors, I have heard that he's an awesome lecturer. We are looking forward for your lecture. Thank you, Aditya.
Sure. Thank you very much for that introduction, and thank you for having me. I have shared my screen now, and please confirm that you can see my first slide.
Yes, we can see.
Perfect. Great. So this presentation is titled Whose English Is It Anyway? Enhancing Language Models for Text Classification Tasks. And this covers some of the research that we have been doing here at UNSW Sydney. I would like to start with an Australian tradition called Acknowledgement of Country. It is a statement to show respect for the traditional owners, traditional custodians of the land, who are the Aboriginal and Torres Strait Islander people. So let me begin by acknowledging the Gadigal people, the traditional owners of the land that I'm talking to you from, and pay respect to the elders past and present. You've already mentioned this in my introduction. I had put this slide because I really wanted to highlight this here, that it really makes me happy that this talk is in a course that, and CFILT is a big part of this course. My CFILT connection started in 2010 with my master's project on sentiment analysis of tweets. And in fact, I was an RA, research assistant, during my MTech, and my interview was taken by Professor Pushpak Bhattacharya. So my journey in NLP started with him in master's and PhD. My PhD was on computational sarcasm, which was published as a monograph. And in 2023, Pushpak sir and I wrote this textbook called Natural Language Processing. Oh, okay. This part of the talk is for a non-NLP audience. So the first time I define a term, I give an abbreviation. That is what I'm doing there. Just a brief background of University of New South Wales. We are a group of 8 university, which is similar to Ivy Leagues or IITs in India. We are ranked 20th in the world according to 2026 QS World Ranking. We were 19th in the 2025 World Ranking. It is a large university. We have 60,000 total students, including 20,000 international students from 137 countries. And it is a very research intensive in the university, as is seen from the research income. I am a senior lecturer in the Computer Science and Engineering School. We are ranked the highest in Australia across multiple subjects. One subject that should stand out here is artificial intelligence. It is a large school. We have 10,000 undergraduate students and 6,000 postgraduate students by coursework and postgraduate by research. So we have MS by research and similar degrees. As a result, there are 75 academic staff members, and of which, in addition to which, there are 29 non-academic staff members in the school. I head the NLP research group here at UNSW, where we have people across the board. The 3 here is meant to indicate masters by research students. If you are interested, please take a look at the GitHub repository, especially after you've heard this talk and if you find some of our research interesting. I wanted to start with a breaking news. This might, I'm sure many of you have already read this, but GPT-5 actually announced, OpenAI recently today announced GPT-5, the model, and said that it had PhD level intelligence. I was intrigued by this title. So I went to GPT-5 and I asked GPT-5 if this claim of PhD level intelligence is true or just marketing. And this is a summary of the answer that I got from GPT-5. where it says a PhD thinks critically, asks questions, and knows what it does not know. GPT models do not. And at the end, GPT-5, on the same day that they announced PhD level intelligence, GPT-5 told me that it's not magic and GPT-5 is far from having PhD level intelligence. I think as funny as this breaking news may be, it sets the premise for what I'm about to discuss in the next hour or so, because I'm really going to highlight the point that LLMs being proposed as a one size fits all solution is far from true, and we must examine claims, especially by commercial providers, with significant skepticism. That brings us to the technical meat of the talk. The first part of this talk will cover two text classification tasks, namely topic classification and sentiment and sarcasm classification. This work is led by my PhD student Dipankar Srirag and is a collaboration with lots of people. Those of you who are who are affiliated with CFILT might recognize at least two names in the two pictures in this slide and at least one name. So we all agree that language models have ushered new opportunities. Language models can be broadly thought of as a sequence to sequence model, where your sequence could be a user input and a model response is the output in the case of a conversation agent. We're also familiar with LM agents that combine a language model with other components or tools, such as a calendar or other API endpoints. This allows the language model to the language model agent to produce an answer or a response to a user input by incorporating information from these other sources. While language models are likely to be deployed in several government and business applications, most technical reports of language models are presented for standard American English. In fact, recent research shows that African American English observes a substantial degradation in performance, and I'm going to show some examples of that. This is also true for Indian English and Singaporean English, which are spoken by a large community of people around the world. And so the claim that we are making is if language models are really the tool of the future, these opportunities are not equally accessible for all users of English. And this is particularly important in the case of Australia, which is a multilingual, multicultural community where people from all around the world live together, where English is the official language. However, language models have not been adequately tested for neither the predominant Australian English dialect or variety, nor the other language varieties that are widely spoken by multicultural communities in Australia. Why does this problem arise? Although English is this graph here shows the proportion of content on the web in different languages, and you see that English occupies almost 50% of the slice. But if you look at the countries or territories where English is an official language, there's a huge list of countries, and we are really talking about all these Englishes, English as a plural. And therefore, our research at UNSW focuses on language varieties. So what is a language variety? A language variety is a characteristic of a particular group of the language's speakers. So you could think of language variety as a national variety where it is on the basis of country of origin. Example is Indian English, British English, Irish English, and so on. Varieties are non-trivial, and here I'm trying to really examine the different layers of NLP. They encompass orthography, syntax, and vocabulary. For example, the word thongs in America means underwear, but in Australia, it means flip-flops or chappals or slippers. And so if somebody asks you, why are you wearing thongs to the class? It is really a question about your footwear. And these differences, these nuances are important when dealing with people from different national origins. Similarly, ambo is a word for ambulance, as in medical ambulance. Another example that actually shows syntax is an example that I tend to use. I'm like this only, where it is observed that placing the adverb at the end of a sentence actually is a trait of Indian English, probably linked to similar syntactic structures in our first languages. Similarly, ya na is a common expression of sarcasm in Australia, where ya na could actually mean agreement or disagreement both. But national varieties are just one way of looking at language varieties. However, the focus of this presentation will be national varieties. Other varieties are really language varieties spoken by specialized populations, like say doctors and lawyers, or language variety is a variety spoken by a person with speaking difficulties. So when we look at language varieties, we are really exploring different forms of language varieties, including and mostly national varieties. So we started with this ACM Computing Surveys paper, and this was on NLP for dialects of a language. And here we showed that we observed from past work that text written in African American English may not even get predicted as English, or may be predicted more commonly as hate speech. This paper also showed that on various glue tasks correspondingly for African American English, many popular models actually perform worse for African American English. Similarly, for generation tasks, it has also been shown, for example, that if you're trying machine translation from and to Portuguese dialects of Portuguese, Bengali, etc., into English, you may observe a significant they observe a significant drop in the performance when the input text in the source language is in a dialect of a language. So we are really looking at the fact that while language models make tall claims, they need to be examined and corrected for different situations, particularly dialects and national varieties. So we also did a tutorial at Coling earlier this year. This we said that NLP takes the low resource view. However, we can really expand that view to lower resource scenarios, because even English being a predominant language of NLP, the language models do not work well for all forms of Englishes, that is national varieties. And it has also been observed, for example, in this EMNLP paper from 2024, where they tested ChatGPT on different types of dialectal text. So the idea here is there's a human chatting with the interacting with ChatGPT, and the human is using one of these varieties, and they count the number of times the human uses features, dialectal features, that is linguistic features associated with these varieties, and the number of times the chat GPT replicates the features. As in, if I'm talking to chat GPT in Indian English, what is the English that chat GPT responds with? And they actually observed that the percent retention of in-variety features was the highest for standard American English, but quite low for many other widely spoken Englishes around the world, particularly Indian English. And there are similar studies which really show that language models of today, even for English, have a default. This was a paper from last year called Dialect Bench, which compared available data sets across different NLP tasks. So you see dependency parsing, pause tagging, etc., across many languages, but for different dialects. And we also observed that for a task like sentiment analysis, which is a textbook task these days, there aren't enough dialectal data sets available. The only ones that are available, and there are lots of them, they are for different dialects of Arabic. And this actually got to me, and the paper that I'm about to describe later in this presentation really was motivated by seeing this long gap in this big table of dialectal datasets. So I asked the question, whose English is it anyway? And our research in this area has been working along this pipeline where we have evaluate and improve. So we have one piece of work where we evaluate a phenomenon and then we try to improve it. And that's just a way to help masters and PhD students interact with each other. So the first paper that I'm about to present was published at Coling Workshop, and you might recognize the second author in this paper. So this part is evaluate, where we are trying to evaluate dialect robustness of language models via conversation understanding. So when we thought of evaluating a conversation understanding, our first question was, what would be a suitable task? And we realized that language models of today are actually based on causal language modeling. That is, next token embedding must capture the context of the text so far so that it is able to predict the most likely token or word at the next position. And therefore, what we did was we tried to find a data set of a conversations where the topic of the conversation is actually the last word of the conversation, which means that if language models really got the complete context, they would be able to predict that topic word very accurately, given that they have seen the rest of the conversation. And so we came across this data set called MD3, which consists of conversations between Indian English speakers and American English speakers. They play the game of taboo. For those of you not familiar with taboo, let me tell you, there's a describer and a guesser. The describer has been given a word, Justin Bieber. She is not allowed to use any of these other restricted words. And she has to explain this word to the guesser, who can ask follow-up questions or make guesses and so on. So here, as you see, given this conversation with the last word masked, where the guesser actually guesses the target word, we provide this conversation to a language model and get it to predict the topic of the conversation or a word or a phrase. We consider two tasks here. The first task is target word prediction, where the language model must predict the topic word from among all the words in the vocabulary. Whereas target word selection is where we convert this to a classification task, where we give it a large number of option words to choose from. So what we do here is we take the MD3 data set and we take the American English and Indian English versions of the data set. And for the American English version, we use a library called multi-value, which is from Stanford NLP lab, where they allow you to translate English sentences from one dialect to another using simple syntactic transformations only. So it does not cover transformations of other kinds, such as lexical transformation. So the idea here was to see if American English converted into Indian English also results in a similar performance as the original Indian English. And one might argue that why are we so worried about Indian English or any other English? Can't we just get a language model to translate or convert it to American English? Wouldn't that fix the problem? And to address that, we actually do exactly that here, where we use GPT to translate our Indian English conversations line by line and collectively to convert a translated data set. So totally, these are what the statistics of the data set look like. So we have a substantial number of training, validation, and test conversations across in American English, Indian English, multi-valued American English, and translated Indian English. So I'll remind you that we experimented with three models, GPT-4, GPT 3.5, and Llama 3. And these are the different subsets that I just talked about. And there are two tasks. TWP is where we are learning to predict among the entire vocabulary. And TWS is where we are selecting among a large set of words. Similarity is cosine similarity between the predicted word and the expected word. Accuracy is it an exact match? So you would imagine that accuracy is a much stricter metric than similarity. So what are some of the observations? We observe that deltas, which is the difference between American and Indian English, all the deltas are negative, indicating that irrespective of whether you use the pre-trained version of the model or the fine-tuned version of the model, there will always be a degradation or a lower performance for a task as simple as, given this conversation, tell me the topic of the conversation. And we often think that text classification, as in classifying if a particular news article is sports or politics or so on, is a rather trivial task. But we observe that in the case of language models for conversations, if a language model is asked to predict the topic of a conversation, they actually do much worse for Indian English as compared to American English. We have some interesting discussion on the type of errors in the paper, and if you've spent any time in CField, you know how important error analysis is and how insightful it can be to enrich your paper. So then we observed a problem. We have a problem here. There is a lower performance for Indian English conversations for topic classification. How can we fix that? So we have a method here in this paper published at NACL 2025, where we present a method for dialect adaptation of language models. So the task here is simpler, is actually more complex, target word prediction. So given a mass dialogue between dialectal speakers playing a game of taboo, predict the target word. And in this case, we considered three language varieties: American English, Indian English, and Nigerian English. So you're thinking, okay, come to the point. You've been saying there's a lot of problem with Indian English. Can we really address it? This is one solution that we propose in this paper. So we propose to train dialect adapters using contrastive learning objective, which is what this architecture looks like. And I'm going to go over the architecture step by step. So the first step is task adapters. So these are classic LoRa style adapters. These are LoRa adapters where we have task adapters which learn to predict the next word in the sequence, the next token in the sequence, given the remaining sequence. And that's what we are optimizing for. We are trying to learn to predict the next word, particularly the topic in this case. However, what makes this architecture work according to me is these dialect adapters, which are trained on pseudo parallel data. So what we really do is we consider conversations about the same target word in American and Indian English as pseudo parallel conversations. Let me pause here and give you the intuition. The idea is that if the target word is Justin Bieber, an American English speaker would describe Justin Bieber in a certain way, while an Indian English speaker would describe Justin Bieber in another way, we are telling the language model that they may have different words, but they are really trying to convey the same meaning. And therefore, you can employ a contrastive loss between the representation from the American variety and the representation from the non-American variety, which in our case, in this case, is Indian English and Nigerian English. So that is what we call LORD. LORD has a full form. I never remember it. Low rank dialect adapters for decoder models. So let's look at some numbers. So we compared Mistral and Gemma here because they allowed us better control on what we were trying to do with the whole contrastive loss and all of that. So we observed that the skyline, which is the performance on the American English dataset, gives you a average similarity of 67.2. The in-dialect baseline, which means that if you only fine-tuned on Indian English, resulted in an average similarity of 52.8. So in the baseline version of the model, there was a gap of, as you see here, between these two numbers. But with LORD, we were able to close the gap and increase the similarity to 59.9. We also tried multiple versions of cross-dialect baselines. So for example, what if you fine-tuned on the American corpus, translated corpus, and so on? And we observed that LORD still gives us the best performance. Similar performances also hold for Nigerian English with the help of LORD. Oops. How am I doing with time? Hello?
Shravanti? Shravanti, can you hear him? Yeah, till class is till 5 o'clock. No problem.
Oh, cool. I can go slow. Okay. Oops. So we really observed that with the help of LORD, we were able to close the gap in the for the task of text classification or topic classification. We also have ablation test results and error analysis in our paper. So that brings me back to the other end of the wheel that I talked about, evaluate and enhance, where we're back to evaluate and improve, where we are back to evaluate. And here I'm going to talk about our paper presented recently at the findings of ACL. The title of the paper is BEST. The source of this name is a bit cryptic. So SST, or Stanford Sentiment Tree Bank, is the tree bank in glue that is used as a standard for sentiment analysis. So we are calling this the BEST of SST. So this is a benchmark for sentiment and sarcasm classification for varieties of English. And just to give you a TLDR, this is a new dialectal benchmark for sentiment and sarcasm classification. So the motivation for this work really came from the dialect bench graph, as I showed you. And when we examined this further, these are the existing benchmarks for sentiment or sarcasm classification of language varieties. While there are lots of benchmarks for sentiment classification, there weren't many benchmarks for sarcasm classification, and certainly no benchmarks for varieties of English. So with Bestie, we have tried to address that gap by reporting a new data set. So how did we go about creating this benchmark? We wanted to consider two kinds of sources, long text and short text. And therefore, we looked at Google Place reviews and Reddit posts as the source of the data. We downloaded Google Place reviews based on the locations of these three countries, Australia, India, and Britain. We downloaded these reviews based on their location by applying location-based filtering. Similarly, for Reddit posts, we identified Reddit topics that were relevant and important in each of these countries, and we downloaded some posts. Following that, we conducted a manual annotation on a subset of each of these three varieties to ascertain the quality of language variety. Similarly, we also reported an automatic evaluation on a BERT fine-tuned to predict language variety, and we selected only the posts and reviews which have a high value in the automatic evaluation here. Once we have these three sets, ENAU indicating Australia, ENIN indicating India, and ENUK indicating UK, we then employed native annotators to label every post and review with sentiment as 1 and 0 and sarcasm as 1 and 0. I acknowledge here that there is a correlation between sentiment and sarcasm because sarcasm is always negative. So these are some examples from the Bestie dataset in the table here from each of these three varieties. And if you look at the statistics here on the right, you notice that the percentage positive sarcasm in the case of UK Google reviews was actually 0%, which means that in this particular benchmark, we do not have a sarcasm labeled dataset for UK English, but we do have it for other forms of Englishes. You also observe that there's a wide difference in the percent of positive and positive sentiment and positive sarcasm. And this was just a function of the data that we managed to collect. We also made sure that the average probability of the text being in English was substantially high, as it is in all of these cases. And the probability of a language variety, as I pointed out earlier, was also high, which is not included in this slide because this is the average number of words in the posts. So we evaluated 9 language models. As you would notice here, these are a mix of encoder and decoder models. These are results for sentiment classification for Google Place reviews and Reddit. You would notice that the performance for Australian and UK English is quite high in each of these cases for Google Place reviews, but it is slightly lower as compared to Google Place reviews for Reddit. In all of these cases, however, the performance is quite significantly worse for Indian English as compared to Australian and UK English. In fact, if you compare these numbers with the GLUE benchmark or the GLUE leaderboard, you would see that even Australian English is reasonably behind American English, at least the leaderboard scores according to SST. The picture is actually different for sarcasm classification. So Australian English and UK English, which had F-score in the 90s for sentiment classification, suddenly observe a much lower F-score for all of these varieties. For each of these varieties, these numbers are in their 60s and 70s, highlighting that sarcasm classification, even in the day of language models or large language models, as they call them, sarcasm classification still remains an impending challenge. So based on our evaluation, if we had to discuss some recommendations for language variety sentiment classification, here are some observations. So we observed that the performance of Indian English on average across these tasks is 0.63, whereas that for Australian and UK English is somewhere around 0.75. We also note that if we aggregate across the encoder models, then the encoder models do much better than the decoder models, which might be unsurprising given that this is a classification task, for example. Similarly, if you look at monolingual models versus multilingual models, we did not observe any significant difference between them, which again goes to show that although Indian speakers are bilingual speakers, they still do not have substantial performance or representation in the American English language models. So that's the summary of the first part of this presentation, where I talked about different text classification tasks for language varieties. We also have a paper that is under review, but I would refer you to the paper on archive if you're interested. This is where we have tried to improve the performance for sarcasm classification. So in a nutshell, we've really been working on text classification tasks in order to evaluate the ability of text topic classification, sentiment classification, and sarcasm classification. And so far, we've also worked on improving the topic classification performance for decoder models using contrastive loss. We would like to grow this list of evaluations and this list of improvements as well. So, and we are also looking for use cases, particularly users with different kinds of linguistic backgrounds. If anyone listening is interested and wants to collaborate, please do reach out. That brings me to the second part of this talk, where we are still talking about text classification tasks. We are still talking about large language models, but we're now going to shift gears and we're going to talk about multilingual hate speech classification. This work was led by Faye, who was an undergraduate student funded by Taste of Research Scholarship, which is a UNSW program for undergraduate students to expose them to research, etc. So the motivation of this work really came from a random thought where I was thinking Transformer actually have translation at its heart. And now that they have grown into these versatile models, which can probably do absolutely everything under the sun, I wanted to examine the ability of translation itself, particularly in the case of hate speech. So the question that we asked was, are nuances of hate speech preserved in translation? This resulted in the paper that I'm about to describe, which we call Is Hate Lost in Translation? We evaluate for multiple languages, English, Italian, Chinese, and code switch Tamil. The task is hate speech detection. And as a particular use case, we looked at datasets, hate speech datasets towards LGBTQIA people, because the social perception towards the community is different in each of these cultures. So when transformer-based translation models are translating between the languages, which aspect, which perspective are they retaining in the translation? Are they preserving the hate speech in translation? So the methodology is rather simple. We obtained benchmark data sets on hate speech detection in the languages that I mentioned. We pre-processed them. We translated them automatically, and that as a result of which we created a translated data set. And then we tested GPT-based models again for pre-trained and fine-tuned versions using these hate speech datasets. So we do the same thing for the datasets in the original language, and we repeat it for the translations of the hate speech sentences in order to see if the labels change or if the performance changes. These are the statistics of our datasets. We use datasets in English, Italian, Chinese, and English Tamil. That is Tamil with code mixed English, but written in Latin script. The datasets are around 1,000 to 6,000 samples big, and these are the distributions across the two labels. So this is a binary text classification task. We experimented with GPT 3.5 Turbo, where we report F1 score precision and recall along with Cohen's kappa. Now, this Cohen's kappa might surprise you here, but the reason that we include this in the metrics is that while F1 score, precision, and recall measure the performance of classification themselves, Cohen's kappa allows us to see if hate is preserved in translation, if the predicted label and goal label really have a correlation with each other. So these are some of the results from the paper. We observe that English has the highest performance again among the 4 languages. We are using the same language model for all of these cases. If you fine tune the language model, there is some improvement in each of these cases, which is unsurprising again. But you observe that for translated versions of Italian, Chinese, and English Tamil, there's actually a degradation in performance, which means that the translation is does not achieve a similar performance for hate speech classification, and there's also quite low agreement between the labels. Similarly, even if you fine tune with translation, there's a comparative improvement, but this is not as good as fine tuning on the original language datasets. So this was just our attempt at seeing if translation, which is at the heart of transformer, is able to retain this important text classification label called hate speech. That brings me to the end of this, close to the end of this presentation. But I would like to take some time to talk about other projects that we are doing in our group, which were not included in this presentation. So we are currently, we like to structure our research as foundational NLP and applied NLP. Foundational NLP must not be confused with foundation models. Foundational NLP refers to foundational NLP tasks and architectures that can help the tasks. So I'll start with foundational NLP. I covered a part of this work where we are working on enhancement of language models for varieties of English, which is a common theme across all of these projects. We've also recently started working with a local hospital where they're trying to deploy a conversation agent in the emergency department where there would be a nurse, and if a patient comes in and the patient does not speak proficient English but speaks English to different degrees, the conversation agent will help the nurse understand the patient. As a result, triage them better, give them better emergency priority rating, etc. So this is something we are working with the hospital here. We also have recently completed a project on multi-token prediction in Transformer. We did this small project for Canva on small-scale bilingual language models. This was a fun experiment with this project called Baby LM, if you know about it. If you do not, please look it up. Baby as in bacha, Baby LM. It is an interesting effort to see how language models work by using small scale data, especially data text that would be seen by a 15-year-old person, I think. We also work on applied NLP projects where we have a project with the Australian Defence on question answering on classified documents. We worked with NSW Department of Education to help them train a translation model which can translate education-related communication that teachers send out. So when teachers send out emails or circulars to parents, they wanted to be able to translate it across multiple languages. We also concluded a project with Cisco where the project was about allowing compliance check on routers. So we use routers at home. Routers have a network configuration setting, which is a structured JSON-like file. But you also have 200-page security standard document given by an organization in security. And you wouldn't really go through the document. You wouldn't understand the nuances of the document. So what we did there was, given your router settings and this 200-page security document, can we highlight the lines in your router setting that may be in violation of some of the statements in the security document. Similarly, on this side, I've talked about this project. We are working on cross-cultural creative narratives. This is with a student with the Department of Linguistics, where we are exploring story retellings, etc. We are also working on NLP for legal domain. And finally, there's this project on NLP for epidemic intelligence, where we are looking at sentiment analysis and stance detection towards public health measures like masks and vaccines and so on across the world. And so we are very much dealing with varieties of English as spoken across the world in this project as well. So yeah, that's it from me. Thank you very much. I'm happy to take any questions, and I hope it was useful.
Yeah, very nice, Aditya. So, class, you please ask questions. You can raise your hand, those online, or you can place it on the chat box, and somebody will monitor it. Or those in the class can ask the question, and then Shravanti can tell you what the question was, if Aditya is not able to hear it. So I think people will begin, but I had a question, Aditya. So this conversion from, it's a canonical English to the dialectical form, not only for English, for any language. Is it a rule-based system?
The state of the art is multi-value, which is a rule-based system, and they apply syntactic transformation. And we have been testing that rule-based system, and it does not produce a good quality output. So in fact, there's a gap for a good translation system between language varieties of English.
Okay. So, but it is not only syntax, but there can be lexical difference, right? So what happens to in that case?
Exactly. So the current state of the art library is the one that only handles syntactic transformations, and therefore lexical transformations or even pragmatic transformations that are required for a sentence to be a valid sentence in a language variety. There is no existing library which automatically allows you to do that.
Okay.
And the rule-based library that I'm mentioning was actually published in 2023.
So to understand this better, let's say I take Bengali, and there is a variety of Bengali called Sileti. Let's consider a dialect of Bengali. And there is a word called Battialoi. Battialoi means small mouse. Okay, very small mouse. So now Choto Idur would be the Bengali expression in canonical Bengali. But Battialoi will be in Sileti. So it's a matter of lexical substitution to get the lexicon. So that, I suppose, is done quite accurately, no?
Yes, in some cases only, but retrieval of context is not always important, or not all does not always happen, because when it detects a language, it tends to detect the mainstream Bengali, the main Bengali variety, for example.
Okay. Okay, so fine. I opened the gate. Now others can ask questions. Those of you who are working on dialect, for example, Vaisula, you can ask questions.
Yes, sir. I've been working with
So you do.
yeah.
Do you have any question?
No, I do not have any questions, sir.
Hmm.
But I enjoyed
Others?
the lecture.
Yeah, sure. Any question on the chat box? Do you see? Yeah, there's a question from Mayank Kothari. My question, you were mentioning during your first paper, I think the workshop paper, that you are looking for a data set where the token word/topic is towards the end. Why is it required? Can't it be in the middle? Yeah.
No,
Aditya?
that's a good point. The only reason we looked at that data set was to employ decoder models which predict the last word after a conversation. We could have well had the topic word in the middle of a conversation and used other forms of other models, for example. And there was a way to predict a word in the middle of the conversation using decoder models as well.
Of course, there are new students in the class who are yet to go through encoder, decoder, and those techniques. In fact, this Monday I'll start with back propagation.
Nice.
Okay, yeah, then they will relate to this. Okay, are there any other questions from the class, from Tight, those online? Okay.
There is another question in the chat, sir.
There is another question. What is it? I can't see it though.
It is mentioned by Sagar Swaraj Mahapatra. So it's that on the paper from ACL evaluating dialect robustness. Since we are only taking textual data into consideration and not speech, how are you telling apart Indian English from American English, bereft of accent?
So in that's a good question. So the conversation English, the conversational data set that we use was created by recording voice and then transcribing it and manually post editing it. So I think the fact that we are seeing this gap, despite removing the challenges so-called to the language model due to the accent, even in its pure textual digital form, we still observe these gaps. I think that is an important challenge for the NLP community in particular to look at. So we have actually abstracted out challenges due to accents in these data sets. And we also have a small project on transcription where we have a comparison of how well does transcription perform for different accents of English.
Sharath has a question from class.
Yeah, what is the
Uh,
question?
So my question is, like in the recent ACL paper, you have mind like ready to get the Indian English, I mean the different dialects of English. Like let's say with the increase in the trend of generating synthetic data in a large scale to generate models or to make models behave in a way we want. What are the tools, techniques, or any like seed data that we can use to generate synthetic data in these specific dialects? Because the normally if we try to generate any synthetic data, it will be skewed towards the major dialect in which the model is trained. So any techniques or suggestions or that you people might have tried in the absence of real world good data?
So that's a very good question, Sharad. It was good meeting you at ACL, by the way. So I think we have mostly tried to collect dialectal data from different sources of the internet. For example, Google Place reviews, YouTube comments, YouTube video transcriptions, and all of that. Language models do default to the standard variety, as you rightly pointed out, and therefore I am not aware of any specific method that can be used to create dialectal varieties. In fact, we tried very simple prompt injection, like saying, "Oh, you are an Indian English speaker. Now convert this sentence." So we tried simple techniques, but none of them seemed to work. So in fact, for the topic of creating synthetic data in dialectal text, I can't think of a solution right now. Not a known solution right now.
Okay. Any more?
One more. There's one more in the chat.
Can you read it? What is it, Shravanti?
Yeah, one second, sir. So while annotating the bestie data set, what were the measures taken to handle bias?
Bias. So I'm not sure which kind of what specific kind of bias you are referring to, but we annotate subsets of the data set by more than one annotators. So we have a subset where we get two annotators, native speakers of the varieties, to give us the labels. That and the kappa scores, etc., are high for that. We report that. We also have some cross variety labeling results in the paper and also performances on the language models, where we show that how well do Indian English annotators perform on labeling Australian English text with sentiment or sarcasm and vice versa. And we do have confusion matrix style values in the paper for that. So I think these are the two forms of biases that we tried to handle. But I also see that given the platforms that we used, there is a selection bias in the source of the data that we collected. Another bias that another bias that I can think of is even assuming that Indian English is one English is not accurate. And therefore, we acknowledge that here we are doing a national level abstraction of English, where we assume that English at the national variety level can be considered a monolith or an atomic unit.
So about social bias, like race, gender, social norms, and so on. For example, the word dowry in Indian English comes preloaded with bias, right?
Yes.
So the question for my question may not be very vague, but do you do anything about such social biases?
Yes, so no, so we haven't done this, but I'm reminded of a paper by Saif Mohammed from ACL 2025, where he created a lexicon. He had a long list of words, and he got American and Canadian annotators to label the same words along the sentiment dimensions and all of that. And he has some observations around how some words may be perceived as positive, negative, and there are other dimensions in different countries and cultures. So I'm just reminded of that paper when you give that the dowry example.
Hmm.
But that really
Emo-
highlights that, sorry, so that really highlights that the when we talk about language varieties, we are really talking about, in some sense, word sense disambiguation. We are talking about social biases. We are talking about uh, pre-training data not being visible or not being very informative, etc.
Hmm. So the word, so let's say a model which is trained on American English and has not seen the word dowry as prominently as it would appear in Indian English, let's say, would would not understand the nuances of the word dowry. The association between dowry and dowry and what should I say, mistreatment of women, and then association between dowry and litigation, and even interning in jail and so on, which is a crime actually. So those associations will not be obtained. And you are very right that the context changes very much during the transformation from origin canonical form to the dialectical form.
That's
Yeah, more questions, comments.
Any more questions from the class? That's all from the class, sir.
Okay. Okay,
I
Aditya,
think,
thanks a lot. Oh, yeah, there is something, Om.
yeah, there was a question asked before the bestie dataset one. So it was asked by Mayank Kotari. During your talk, you mentioned that the African English text was predicted to be hate speech. Why is that? Is it due to specific word choices or overall flow? Can you please provide more details?
Sure. So the paper that I described for African American English and hate speech, they examine that and they say that because there are the bias there comes from the presence of labeled hate speech data sets in the pre-training corpus. So because the hate speech data sets that have been known for English in the past are have more evidences of hateful speech being labeled with a certain language variety, that information seems to be affecting the performance. And there are some details of that in the paper. So it is a function of the biased labeled data sets within the pre-training corpus.
Okay.
Great. I just want to say one last thing. I was a student of Center for Indian Language Technology. That's what it was called back then. Pushpak Bhattacharya's rich career is based on Indian language technology. And as I'm trying to set up my career in Australia, I'm really adapting the Indian language paradigm to the Australian setting, where I see language variety of English as a prominent theme. So I just wanted to acknowledge that at the end of this talk.
Mhm. Thanks. So, Aditya, I think you should also deeply investigate Australian Aboriginal languages and bring them from the fringe of the landscape to the mainstream, if possible. Creation of data models, NLP tools, and so on. So one of the students in Civil, Sanjeev, he is working on Bihari languages, Angika Maghi and Maithili, and those are dialects of. I don't know if they can be called dialects of Hindi, very similar to Hindi. Maithili is influenced deeply by Hindi and Bengali. So it is one of my passions these days to bring low resource languages to a stage where they can enjoy the blessings of NLP.
That's very nice. Yes.
Yeah. Okay, so if no more questions, then let's thank Aditya once again. Maybe you can press on the clap icon. Yeah. And thanks a lot, Aditya.
Thank you. Thanks, everyone. Bye.
So your
Yeah.
recording will be
Thank
there. Yeah. So Shravanti, you want to make some announcement about the venue and all those things?
Yes, sir, I'll do.
Okay, then I'm signing off. You do that.
Yeah, sure, sir.